to hand it over to Rosen.
Thanks, Molly. So good morning. Thank you for staying awake, at least to this point. So what I'm actually going to talk about is kind of a nice complement to what Addison just talked about. So Addison discussed a lot of the trends in big data, what's the difference between big data and Hadoop, kind of, said some things that probably led you to conclude that Hadoop is a technology still looking for a problem to solve. I'm actually going to talk about a specific problem that Hadoop is solving in the enterprise today that's very interesting to people. And I'll try to put a storage slant on it because I came from a storage company, NetApp, several years ago. So a lot of what I'll talk about today, I'll try to put into a storage framework because there's some similarities to what you're probably thinking about from an enterprise data perspective at the storage layer versus what's happening a couple layers up at the data, structured data and unstructured data levels. So that's a little bit about me. And by the way, I don't consider myself a Unix pioneer. I worked for a Unix pioneer many years ago, but I still have some scars on my back, and I don't really want to talk too much about that because it's pretty traumatic. So anyway, let's talk a little bit about data warehousing. First of all, before I even kind of go down this road, let me ask, is anybody in this room doing anything actively with data warehousing in Hadoop right now? Excellent, okay. And in terms of Hadoop in general, is anybody actually running a production Hadoop cluster? Okay, I didn't think so. That's actually, it's a rare thing these days, and that's another kind of a separate discussion, but Hadoop in general is a very interesting set of extremely complex and strangely named technologies. So people are still trying to figure out what can I do with it. And this is a very interesting problem around enterprise data warehouse offload and optimization for a number of reasons, but the biggest reason is that it's really, really expensive to maintain enterprise data warehouses and try to figure out what to do with unstructured data as opposed to structured data. That's a big problem in the enterprise data warehouse world. So I'll talk a little bit about how Hadoop can help solve that problem. But anyway, if you look at the sort of enterprise data warehouse market, there was a prediction that Gartner made a couple of years ago, back in 2010, that there's a huge scalability issue looming on the horizon for EDWs, and it turns out they're absolutely right. Part of it really has to do with just the dynamics of companies relying more on data to solve business decisions, but a big part of it is the difference between growth rates in structured data versus unstructured data. So you guys are all in the storage business, so you know that the vast majority of data that's being generated these days is actually unstructured or semi-structured data. It's coming from iPhones, it's coming from device sensors. This is data that is very difficult to figure out what to do with. And most companies feel like they ought to be doing something with it, but they're not really sure what, and to solve it in terms of just sort of storing it is a huge problem. So there's a real sort of dynamic in the market right now that's driving some of the overwhelm that the enterprise data warehouse community is feeling. And also because the world as a whole is getting much more data-driven, and companies like Google and Facebook are really sort of promoting the idea that data is your future and analyzing data is the way to make appropriate decisions. So expectations are going up on the end user side. The ability to deliver against those expectations is being challenged by the complexity of technologies like Hadoop. So there's a real conundrum here that Gartner, I think, correctly predicted was going to happen a couple of years ago. Excuse me. So about 6 months ago, an organization called the Data Warehouse Institute came out with a report that really talked about the potential of Hadoop to address some of these issues. And here's a classic question, right? Is this a problem or an opportunity? And most of you are probably familiar with this notion that problem and opportunity are basically two sides of the same coin. And the answer largely was it's an opportunity, but there's also a problem here. And Hadoop, in the context of a data warehouse, enables new kinds of processing and delivers context. That's really what people are looking for. If you're a company who is in the product business, you're trying to figure out what are consumers of my product or brand thinking when they make a decision about doing business in my company. If they're buying something off a website, you kind of want to know what is the perception of your brand and your product as they go through that exercise, because they may or may not go the direction you want them to go. But understanding that context around why are they making these decisions, that's really important. So Hadoop can really actually open up the capability to get to those decisions and understand what your consumers of your service or your product or your brand are thinking as they integrate or engage with you in their business. But the challenge is that Hadoop is this very complex technology. It's written by geeks, for geeks. It's open source. There's strangely named modules like Pig and Hive and Scoop and Oozy, and that's just the sort of popularly known modules. So how do you figure out how to use this stuff? How do you get people trained on it? How do you find the talent in the market? And then once you get all that done, how do you figure out what kind of problem you can solve with it? So it's a great opportunity, but it's also a great challenge. And this has a lot of people kind of up in arms right now. So if you look at the kinds of problems that organizations are thinking they can solve with Hadoop, it really kind of gets lumped into two different groups. And this is the survey results from one of the surveys in the study I just showed you. When people think about the kinds of problems they can solve with Hadoop, this is the sort of spectrum of answers they came up with. And you can really lump these into really two different categories. You can think of, in fact, this graphic didn't come out very well. You can't see the light colors here, but a subset of these answers are related to competitive advantage, which really translates into top-line revenue enhancement, right? So some of the problems you can solve with Hadoop in the context of a data warehouse actually allow you to raise your revenue and get better understanding of what your customers are doing. That's very strategically attractive to the CEO, right? If you can raise your revenue by making an investment in this technology, you're probably going to do it, but you have to be able to prove that you can do that. The other angle, which is where most companies actually get started with Hadoop, is around operational efficiency. And what that translates into is lowering your cost structure. So if you can solve an existing problem more efficiently with Hadoop by leveraging the fact that it's open source and can be deployed on commodity hardware, well, then you have a play in terms of potentially lowering your cost associated with a specific problem you're trying to solve with enterprise technology. And the cool thing about some of these technologies, before I actually leave that slide, some of the problems you can solve with Hadoop actually will help you both raise your top-line revenue and lower your costs. That's actually an example of Hadoop in terms of data warehouse offload. That's actually a play that you can run where you can raise your revenue and reduce your cost if you do it right. The challenge is that not that many people know how to do it yet. It's still pretty early days, but I'll talk about some of the dynamics associated with that. Okay, so this is kind of a statement that I discovered myself only too well. I actually came to Pentaho, and I've only been with Pentaho for a couple of weeks. They're a BI software company. They help you actually visualize and do data integration with technologies like Hadoop, as well as with legacy enterprise data warehouse types of data sources and relational structures. Before that, I actually was at a Hadoop software distributor called Mapware Technologies. So what I learned pretty quickly when I got into the Hadoop world with both feet is that it's very, very hard. It's hard to get it up and running. It's hard to integrate it. It's extremely complex. It's just conceptually difficult to get your hands around. And that's actually a dragging factor in terms of when people try to get into Hadoop and figure out how to solve a problem in the context of an enterprise technology deployment. They're going to run into a lot of issues as they get through, the sort of deployment lifecycle. Most of the companies who were surveyed in this previous environment said, yeah, finding the talent is really hard. Manually coding a lot of the technologies that I need to deploy to solve a problem, that's actually very difficult. And it just really adds to the drag associated with deploying Hadoop. So, most people will take them 12 to 18 months to see a real result out of a Hadoop deployment, and that's at a small scale. The way most companies typically do things with Hadoop is they'll basically start off a pilot, get a small cluster up and running, try to solve a specific problem, get their sort of hands dirty with it, and then once they get some confidence around it, they'll actually take it further and start to deploy multiple use cases on that same technology set. But there are very few companies who've actually gotten to that point. In fact, my guess is it's probably about 100 or so worldwide who are actually doing production Hadoop deployments. And that's just because it's so complicated. There's so much stuff you have to learn. All the different layers that need to be integrated, very complex. So that's a big challenge. And you guys probably already figured that out after you listened to Addison talk. So if you actually go into CIO's minds and you drill down on what are the things they're really worried about, number one thing there is finding the talent, right? The second thing is getting sponsorship from the business, because once you have a clear idea of what problem you're trying to solve, it's really hard to get, a VP of marketing to sort of fork up, I don't know, $750,000 to deploy a Hadoop cluster to solve a problem. Unless you can be really clear about what problem you're solving there, they're probably not going to cough up that money. So getting that really clear business case identified is a big challenge for a lot of companies. Any questions so far on what I'm talking about? Is this resonating with your own experience?
So what your bottom line then is that it's better for other people, for the marketing department to create the problems and give it to the cloud for those other people, so the service providers to solve rather than try to bring it into the data center yourself?
Well, yes and no. So there's a challenge there, right? Because as Addison mentioned earlier, cloud is a good way to solve certain classes of problems, but actually getting data from here to there is a challenge. Doing it securely is even more of a challenge. So I actually see a fair number of people deploying Hadoop in the cloud on structures like Amazon Web Technologies. And they're doing that fairly successfully, usually if their data is already in the cloud. So for consumer companies or companies who are doing business primarily or exclusively over the web, all the clickstream data is probably already up in the cloud anyway. So they can solve a Hadoop problem efficiently in the cloud because that's where the data already is. For most enterprises, most of their data that they want to analyze, as Addison mentioned, is actually inside the enterprise. So moving that up to the cloud is a challenge from a security perspective. It's a challenge from just getting the bits up there because the data sets are pretty large. So companies might try to do an internal cloud deployment, but they'll typically do Hadoop on a on-prem, non-virtualized sort of form factor because the performance is better and it's a little bit more controllable. So you can still solve the problems. You don't just have to hand it over to a systems integrator, but SIs can definitely help because they tend to be very well schooled at solving specific classes of problems, especially if they resonate with specific vertical markets. And we're going to talk today about enterprise data warehouse offload, which from a Hadoop perspective, that resonates really well in retail, in financial services, and in telco. In fact, I have a specific telco example I'm going to put from here. Yes?
So where did you get the statistics from? Is that from polling your customer base?
So I believe these stats actually came out of the TDWI report that I referred to earlier. I actually didn't come up with this presentation. Somebody else at Pentaho did, but I believe that's where we actually got the stats out of. So this is kind of the risk that you run from an end user perspective, right? If it's hard to figure out, if it's hard to deploy, people can't understand it, you know, what do I do? Where do I get started with this? Because just kind of ignoring it is probably not the best approach. The real trick is to figure out what problem can I solve. And Hadoop vendors in general are reasonably good at talking about not just what the technology is, but here's the class of problems that are very well addressable or nicely addressable by Hadoop. And then you have to kind of go into a subset of those problems and say which sort of solutions here really resonate with my company and my vertical market. Once you figure that out, then it's time to actually look at a pilot and potentially go deploy to production. That's really the challenge. What problem can I solve with Hadoop? And that's true for any new technology, right? I spent a little bit of time in the HPC world many years ago, and back then, when it was first getting started, the real challenge was, well, what kind of problems can we solve with this? And outside of government and academic environments, it wasn't necessarily clear. Financial services figured out a couple key use cases and went with that, but it took a while. So that's really the question you want to ask yourself. What problem can I solve with this stuff? So here's actually a specific problem we'll talk about, and it's a telco-specific problem. I've actually worked with a couple different companies in the telco vertical market who are trying to solve problems using Hadoop and using enterprise data warehouse. And this is an example of a classic business problem. It's actually an abstraction of a real-life problem that we worked on. But in this case, it's a telco who actually said, okay, I've got some excess capacity in my network. I'd like to be able to resell that to somebody else, but I can't do that if it's going to impact my service levels. So before I even sort of formulate the idea of allowing my sales team to go out and sell this excess capacity, I better figure out where that capacity really is, so I don't actually destroy my core user base by, you know, getting a little too interested in generating extra revenue at the expense of my existing customers. So in this case, the question you want to be asking yourself if you're a telco CIO is, all right, well, where is my excess capacity, and where don't I want to actually sell it? So this particular problem here is, all right, if I've got, you know, some subset of my audience that's generating a lot of outbound calls on the weekend, which is when I have my excess capacity, I don't want to go there and sell that capacity because I'm already seeing too much demand in that area. So there's a couple different data sources you need to actually pull in to figure out this problem. The first one is, you know, who's actually making the calls? What do the calls look like? And that's call data records, right? You guys familiar with call data records? Is it just an idea, conception? It's basically log data, right? Here's who made the call, when did I make it, who originated the call, where did it go to, how long was it? That's a log. It's basically semi-structured data, and it's pretty consistent. There's a whole bunch of that data coming out there, not surprisingly. But the other information you need to know is, all right, well, where is this data actually breaking down? Where can I kind of do some analysis? So I need to sort of map that against area codes and figure out, based on that data, where is my density of outbound calls happening? And from that, I can figure out where I should be selling this excess capacity. So that's kind of the core problem that we're going to try to focus on with this particular example. So if you look at that problem from a traditional enterprise data warehouse architecture, this is the reference architecture for a data warehouse if you're not familiar with it. We got a whole bunch of structured data, which is classic transactional data that's stored in a relational database typically. And you go through this process called extract, transform, and load, or ETL for short. Sometimes it's called ELT if you can parallelize that process. Anybody in the room familiar with ELT or ETL? Okay, great. It's a fairly straightforward exercise. It's been productized to a large degree by companies like Informatica over the last several years. When I got into ETL 25 years ago, it wasn't called ETL, it was just scripting, right? I was just munging data from all these different Unix sources and doing unholy things with it. And that was a traumatic experience that I don't want to go too far into. But the good news is that that's a very mature business. ETL is provided by a number of different vendors out there. So typically what you do is you extract your structured data, you put it through an ETL process and run it through a data pipeline. You munch the data, format it correctly, then you load it into a data warehouse or a data mart where you can run your analytics. So this is sort of the traditional reference architecture for an enterprise data warehouse. Now the challenge is, if you're trying to figure out what context is and what people are thinking about your product or your solution, as they sort of go through these transactional exercises with your brand, you need unstructured data to complement the structured data that you already have. And that's where Hadoop kind of comes into play. So in this case, this is just kind of an illustration of where we actually would solve the problem for deciding to do it with a traditional EDW reference architecture. So here's the problem with that approach, right? As you start increasing the volume of data that's being processed by your data warehouse, you're actually dragging down the response time that people are seeing when they're trying to do interactive queries against that data, run analytics on it. And most companies that have mature EDW infrastructures have executives who are running dashboards and who want to be able to do drill downs on an ad hoc basis. And the more data that you stick into this data warehouse, the more difficult it's going to be for those people to get a quick response. So these are people who you don't really want to piss off because they're executives in your company. So people get a little anxious when they look at sort of inserting a whole bunch more data into this data warehouse because you could be slowing down the response times for the executives who are using this data, consuming the reports. Also, it's really, really expensive to store data in a data warehouse. I'll get to your question in just a second. Most of us, think, since you're in the storage business, you think of data in terms of how much does it cost per terabyte to store this data. And, I'm trying to remember some of the figures I used to throw around when I was in the storage business, but 50 cents to $1 per gigabyte was sort of the working average a couple of years ago when I was working that out. But if you look at the cost in the data warehouse context, to actually store a terabyte of data, and it runs anywhere between $15,000 to $100,000 per terabyte of data. Now, storing that data in a sort of open source commodity hardware environment, it's probably going to run fully loaded somewhere between $500 and $1,000 per terabyte. So there's a huge cost differential between the legacy environments where you're storing this data doing analytics versus the emerging environments that are open source and commodity hardware based. And that's driving a whole bunch of people to sort of look at this and say, well, do I really want to stuff all this data in, risk, lowering my response time, raising my costs, which are already astronomically high, if I don't have all the money in the world to be able to handle this, right? And that's the case with most people, right? They don't really want to be spending $4 or $5 or $6 million a quarter or every 2 quarters or a year to expand their data warehouse if they can find a more cost-effective alternative to do that. So this is kind of a conundrum, right? You've got these expectations. You want to be able to get the context around the transactional data that people are using to make decisions about how to engage with your brand, but you're going to need a lot of money if you're going to expand it the traditional way, and you might risk lowering your response time for end users. I think there were a question or two on the slide.
The response time gets bad because of joinings.
That's part of it, yeah.
Okay.
It's just general pressure, right? And just like any other sort of storage system, you guys are all technologists. The more pressure you put from an I/O perspective on your storage system, the better the chances are that the latency is going to increase. And whenever you're doing ad hoc types of queries, the expectation on the part of an end user is, I'm going to get my response within a second or two, right? And sometimes microseconds, if you've actually got a machine on the other end that's trying to process the data in the context of a data workflow. But the more pressure you're putting on your I/O layer, the more challenging maintaining that latency at a predictable layer is going to be.
So is it the size of the different databases? Joining is one of them. The other one is the I/Os from each and every part
Yeah,
of it.
the queries that it's really coming from 2 areas. It's just like any other sort of storage technology. It's the ingest rate. If you're ingesting a large volume of data, that puts a lot of pressure on the I/O layer. And if you're actually doing queries which are scanning these databases over many spindles, that's also putting pressure. So you're getting it from an ingest perspective, you're getting it from a interactive I/O demand perspective. So you're getting slammed if you start putting too much data in.
Well, compute.
And compute as well. So that's a really good question.
Takes longer.
Yeah, really good point. So add that on top, right? The more complex your joins become, the more compute time is required to actually process those. And just getting the data out of the spindles into the compute environment to be able to do that is adding more pressure. So the complexity of the joins, the I/O ingest rates, and just basically the volume of interactive queries that you're getting, all of those kind of conspire together to raise the temperature. And if you throw a whole bunch of data coming in that's trying to give you context around what the transactional data looks like, that's just going to make the problem worse. So, this is actually not all that different from any other workload that you guys as storage professionals will be looking at adding, right? If you've already got an existing level of pressure in your environment, adding a new sort of workload that has a very large input rate, potentially, and trying to satisfy expectations of your end users, that can be a real challenge. So this isn't really any different than anything else you've looked at in terms of adding new workloads in. The biggest difference is that the volume of data bringing in can be huge, and it's unstructured and unstructured data. And it's going to grow very quickly. Okay, so these are some of the challenges that you tend to see if you're trying to sort of figure out how to solve this problem effectively. So this is an example of a reference architecture of how to solve this problem by deploying Hadoop as a technology in front of the enterprise data warehouse. So what you're actually doing here is actually leveraging the fact that Hadoop can be deployed on commodity hardware, it's open source software, so the storage cost per terabyte is dramatically less than what you would see in an enterprise data context. The differentials I talked about earlier are anywhere between 50 and 100x typically. So when you see that kind of cost differential, that gets people really interested because the potential here of actually being able to lower your costs from an infrastructure management perspective and still be able to get the contextual information you need to figure out what your customers are doing with your product or service, that's pretty huge. And just to sort of tell you a real life story, I worked with one telco about a year and a half ago who decided to deploy this enterprise data warehouse model with Hadoop as a front end. Their calculation was that they would save $30 million over the next 5 years by either delaying or reducing entirely the need to expand their data warehouse, but still be able to get the sort of interactive context they were looking for from unstructured data. So that was kind of a no-brainer decision for the CIO, and he fast-tracked that decision, which was pretty remarkable given the size of that organization. It's hard to fast-track anything there. Questions?
Since Hadoop is batch-oriented, so the conflict is the desire of being interactive, right?
Right.
So how was that something?
So great question. So Hadoop, you're right. Hadoop is historically, it was designed initially for batch-oriented workloads. For those of you who are not familiar with the history around Hadoop, the original design goal for Hadoop was actually to munge a whole bunch of log data from web servers so that the folks at Yahoo could figure out, what does the demand curve look like inside my environment, and am I still being able to satisfy my business goals? And that was 8 or 9 years ago when Hadoop was first designed. That said, the interest for most people for Hadoop is actually moving from batch-oriented workloads to more interactive workloads. And there's a whole frontier of new technologies that are at the cutting edge of Hadoop adoption around implementing solutions like SQL over Hadoop. So if you're a vendor like Cloudera, which is probably the leading brand in the Hadoop space, they introduced a technology about 6 months ago called Impala, which delivers SQL over Hadoop
How
capability.
was solved in the cloud?
I'm sorry? Oh, how did the telco actually solve it?
Yeah, because that's a few years ago.
Yeah.
Such an interactive, oriented technologies were not quite available back then.
Exactly. So a year and a half ago, the legacy technology that was really deployed for interactive experience with Hadoop is Hive. So Hive runs MapReduce in the background, so it's not very fast. You can do some queries on fairly small levels of data, but as the data sets really grow, the demand to actually do MapReduce over a very large data set before you get an interactive response back, that doesn't work very well. So the community has kind of evolved to the point now where the data sets are large enough so that having a technology like Impala or Drill, which is an Apache initiative that a number of companies are behind, those will help reduce the latency associated with doing interactive queries in Hadoop. So it's evolving, but this is a very kind of dynamic edge of a cutting edge technology. So there's a number of solutions that will be out in the next probably 6 to 12 months that will allow you to do interactive queries over Hadoop data sets much more efficiently than doing something like Hive, which is more batch oriented because the MapReduce backend. So anyway, back to this reference architecture. So the idea here is that if you deploy a reference architecture like this, it actually allows you to complement the traditional structured data set that you've done or used for your traditional enterprise data warehouse transactional analysis with unstructured data, which you still want to ETL, but you would ETL it into a Hadoop cluster. And once it's there, you can take advantage of the fact that Hadoop is designed to accommodate not just structured data sets, but also unstructured or semi-structured data sets. So when you combine those two data sets together, you get a little bit more complexity in the ETL layer, but it allows you to get the kind of context that most companies really want to look at when they're trying to figure out what are people really doing with my brand as they analyze data through the data warehouse. So you get the contextual information that you're looking for. And the other interesting pattern here is that you also have the ability to treat your Hadoop cluster as an active archive if you want, because the other sort of interesting trend with Hadoop is, or with enterprise data warehouse technologies, is that a lot of people stuff data into a data warehouse, but it gets old after a time, and keeping it in an enterprise data warehouse is very expensive. So you can, if you deploy this sort of a reference architecture, you have the ability to take your older data sets, if you can find them in your data warehouse, and move those onto Hadoop, where you can still do analytics. You can still do your own tail analytics on it. potentially even with the traditional tools that you use with your data warehouse environment. But it's a much more cost-effective place to store it. And there's actually a whole breed of smaller software companies that are emerging whose only focus it is to go sort of parse through your legacy enterprise data warehouse data sets and find the older data that you can then migrate over to a Hadoop environment. So if you're a storage person, you can look at this reference architecture, and to me it actually felt like this is actually very similar to a traditional data tiering model that you would see in a storage context, where you've got your very low latency, high speed, flash memory type of devices dealing with your hot data. You've got sort of mid-range SATA and SAS drives dealing with your data that's not quite as hot, maybe medium temperature, and then you have an archive layer which traditionally has gone to tape. In this case, Hadoop is capable of handling that medium temperature and that colder temperature data all in spinning media. Or if you want, you can actually put SSDs in Hadoop as well and get some leverage out of certain low latency operations that way. So this kind of looks like a data tiering model from a storage perspective, but that's basically the solution you're deploying. It's just in an enterprise data warehouse context using Hadoop for front-end technology. So if you do that, you really get a number of benefits. You can still get the contextual information you're looking for by analyzing this unstructured and semi-structured data that surrounds the transactions that you're trying to analyze. But you also lower the temperature of what's going on in your enterprise data warehouse because you can offload a lot of the older data sets onto Hadoop and free up some compute headroom and some storage headroom that makes it cheaper and much faster. Does that make sense to everybody? Now, the trick here is that this is not, just because it conceptually might look straightforward, doesn't mean it's actually easy to implement. If you look at enterprise data warehouse deployments with customers, every one is different. And the reason for that is that your data sets, your data sorts are all different. Everybody's got their own sort of, very specific transactional data sets that they keep inside. They may or may not be looking for social media context, but how they actually do that for their end users changes from company to company. So you might be able to replicate this reference architecture, but actually deploying it tends to be a fairly lengthy exercise because you have to go in and assess what are all your existing ETL processes looking like. It's typically not all implemented with one vendor. You've got multiple different ETL vendors. You've got some hand-coded ETL that people have done. So going through and assessing where is all this data, what do these ETL processes look like? Should I wire them into my Hadoop front end? That's kind of a discovery process that can take a fair amount of time. If you've got a lot of data, you've got a lot of legacy ETL processes to go through. But the result is still extremely powerful financially and operationally because you can really get to the point where you can raise your top level revenue if you do it right, and you can lower your bottom line costs associated with maintaining this environment. So this is this can be a very common first choice for Hadoop use cases in an enterprise. It's conceptually fairly straightforward. It can just take some time to get through because you've got to go through that discovery process around your ETL and your legacy data sets. And you also have to typically train people on how to use Hadoop. Question?
I see ETL in two places. Would you use the same step two, the same step vendor, so there's some vendors that are for one?
Yeah, that's a great question. That's a great question. So the question, if you didn't hear it, is, it looks like you're kind of using ETL in two different places. Do those ETL solutions come from two different vendors potentially? And the answer is sometimes. It really depends on what your data sets look like. What we've seen is that typically the larger the organization gets, the greater the chances are that there are already multiple ETL technologies in play anyway, and multiple vendors in play anyway, right? Just like with Hadoop, you very rarely see companies actually deploying only one Hadoop distribution inside an enterprise. The only company I've seen who's done that is GE, and that's because they spent $100 million with Pentaho, right? So they bought the license effectively to deploy one technology internally, or one specific distribution internally. But everybody else I've seen has multiple Hadoop distributions in deployment in various phases inside the enterprise. So the key here is to understand what the ETL technologies are actually doing in each one of these phases, right? So a sort of outbound ETL technology, that's actually doing the data ingest and sort of the initial parsing and cleansing. You use the same ETL technology a slightly different way in the second phase where you're actually doing bulk loading and more ingest directly into the traditional enterprise data warehouse. And that can be done with this one technology vendor, it can be done with multiple technology vendors.
Quick question, why use multiple distribution, Hadoop distribution?
Great question. So the question, if you didn't hear it, is why would anybody want to use multiple Hadoop distributions? And there's a good answer for that. And to understand it, you have to understand how Hadoop has evolved in the market in the last couple of years. So Hadoop is an open source technology, right? And the canonical location for it is the Apache Software Foundation. So you might think that even though there's at this point like half a dozen popular Hadoop distributions out there, they all pretty much have to be the same code, right? Why would you want to go to different distros if it's all the same code? And the answer is it's actually pretty much open core, meaning the modules like Pig and Hive and MapReduce and Scoop and Uzi All that stuff is pretty much the same from distro to distro. And how the distribution vendors are actually differentiating in the market really has to do with what they do at the bottom and what they do at the top of that stack. So for a company like MapR, which I used to work for, they're differentiating both at the bottom and the top, but mostly at the bottom around the file system. Because Hadoop, as a file system, is the file system that it offers out to store all this data is a virtualized file system called HDFS. And it's implemented as a virtualized layer on top of the traditional Linux file systems, ext3 and ext4. So the challenge with a file system, as all of you guys probably know, is that virtualizing a file system is probably not going to lead to really good performance for demanding workloads. File systems are just not something you tend to see virtualized because it's a very performance-sensitive layer of technology. So MapR solved that problem in one specific way by implementing the HDFS protocols as well as the NFS protocols on top of their own file system. So that's how they differentiate in the market, but the rest of the modules are pretty much the same. If you look at Cloudera, the way they're differentiating is that they're actually putting in semi-closed or closed interfaces on top of the stack, like Impala, like Sentry, which is a security-related solution, like Navigator, which is kind of a data entitlement solution. So different companies are differentiating in different ways in the market, and which distribution you want to consume kind of depends on what kind of problem you're trying to solve, right? But typically the adoption with Hadoop in the market is, you'll see a large enterprise have different pockets with DevOps teams deploying a specific distribution to solve a specific problem. And over time, that will probably get to the point where a large company will standardize on one specific distribution, but we're many years away from that, in my opinion. It's just way too complex a dynamic market right now. Question?
With this architecture, what is the time to data between this one and the typical?
Yeah, so are you talking about it from like an interactive query perspective?
Because you're injecting a lot.
Yeah, so that's a great question. So it really depends on where the data actually sits that you're trying to query. For a traditional legacy sort of a query where you're hitting the data warehouse, it's really not going to change. In fact, it'll probably get better because you've lowered the operational temperature inside your data warehouse. So if you move some of that data off to this Hadoop front end, you're giving yourself more compute headroom and more I/O headroom to be able to process the same queries as before. But for different types of queries that you're actually going to use, maybe to take a look at unstructured and structured data in combination, where you're sort of traversing both sides of the equation, that can be anywhere from a couple of seconds to, depending on how you're doing it, several minutes, and how big the data sets are. And that kind of goes back to the earlier question around Hadoop being a batch-oriented technology, right? So Hive is the legacy interface that's been presented up to sort of consume and deliver ad hoc queries, but those are not really interactive in most people's experience. So if you have a very small data set, you can get that query done quickly. If it's a large data set, you're going to be running MapReduce in the background. That's going to take much longer. So as the SQL over Hadoop solution sets mature in the market, you'll actually see that latency really shrink because those solutions are really designed to do some very interesting caching kinds of technologies to remove a lot of the latency out of those large data set queries. So right now, you can see a fairly big delta between the queries that you're doing on structured and unstructured data together versus the legacy queries that you've done just in your data warehouse alone. Over time, that delta is going to shrink, so it won't nearly be quite as big. And that will make this overall solution much more usable as it mainstreams into the enterprise as a whole.
So if I replace the data warehouse, warehouse solution with Hadoop.
That's a great question. And if you didn't hear it, the question was, have you seen anybody actually replace their data warehouses with Hadoop? So I hear a lot of questions from CIOs saying, I'd love to reduce or replace my data warehouse because it's really freaking expensive. But realistically, is that even really possible? And the answer is, if you're using your data warehouse in a significant way, the chances of you doing that right now are probably, successfully, are probably very close to zero, right? Because all the legacy technology that's built up in a data warehouse stack, which has matured over 20 years, that's pretty complex technology, right? And to sort of myopically think that you can just sort of throw all that stuff to the side and expect a Hadoop stack to solve that problem for you right now is not realistic. Hadoop is evolving very quickly. It's very, very early days, even though the technology's been out for 8 or 9 years. So I wouldn't see any significant chance of doing that running kind of successfully for probably at least 4 or 5 years. And that would correlate to how widely you deploy your enterprise data warehouse. So frankly, when I heard customers tell me that that was their goal and I was a Hadoop distribution vendor, I'd say, dude, you're smoking crack. This isn't going to happen. Let me help you sort of get your handle on it by getting your feet wet first. Take a couple of subsets of your operations, see some initial value there, and over time you can start to slowly migrate some of your workload from your enterprise environment over to a Hadoop front end. And then maybe in 5 years from now you can turn off your enterprise data warehouse. But the interesting context here is that it leads a lot of the legacy data warehouse vendors to get very nervous when they think about Hadoop, right? And if you look at their strategies, They've been maybe tentative, at best would be the word I would describe, because they're not really sure if they're letting the fox into the hen house or not. And some of these companies, it's kind of interesting, I was on a panel about a year ago with one company who was a leading vendor in enterprise data warehouse, and I think they were so scared of Hadoop, they actually referred to it as an honorific. So this guy next to me was saying, well, if you want to deploy an Hadoop, the way you would do the Hadoop is that you'd actually do this and you do that. And he gave Hadoop an honorific, which to me felt like, all right, this guy's actually pretty spooked about what Hadoop could be doing to his legacy business. And there's a good reason for that, because the more you open your door to let your customers sort of take your core data and move it out to a different storage layer, the more threatened you might be over the long term. And this is, enterprise data warehouse technology is a very margin-rich sort of solution, right? People have gotten very, very rich deploying these solutions over the last 20 years. But it's ripe for disruption because of the nature of the open source commodity approach that Hadoop offers to solving this problem. It's just not realistic to think that it's going to happen overnight. Question?
So, a couple of questions. Oracle, how are they using the connectors between these two? And then the rise of SQL, how does that fit into this model?
Yeah, great question. So, for those of you who didn't hear the question, Oracle and how do they implement connectors as a whole? So what you see with most legacy relational database environments, and you can include enterprise data warehouse solutions as part of that, is that they'll actually leverage a module that comes with Hadoop, which is called Scoop, which is designed to do kind of bulk import sorts of solutions. So what you'll typically see if you're a Teradata or you're an Oracle is a Scoop-based solution that allows you to do bulk import and export and get data out of one environment into Hadoop or vice versa. But it's usually getting data out of the relational environment into Hadoop. In terms of the actual query layer, it kind of comes back to that leading edge that I was talking about a little bit earlier around SQL over Hadoop. And there's a number of different solutions that are in play right now. Very few of them, in fact, none of them are really truly mature because they're all relatively new. The one that's got the most road time on it is Impala from Cloudera. But there are some open source initiatives that are going to be coming to fruition next year. There's a new technology that Hortonworks is deploying or advocating called Stinger, which is part of the open source Hadoop stack, so all the Hadoop vendors will have access to that. And these are all designed to facilitate interactive queries over Hadoop in a much more rapid fashion than something like Hive, which is much slower because it has a MapReduce backend. They're also designed to implement a larger subset of the SQL 92 or SQL 2003 sorts of requirements. So that's a very dynamic part of the spectrum. It's maturing over the next 6 to 12 months. So next year is going to be a very interesting time for the SQL over Hadoop space. Other comments or questions on this reference architecture? Okay. So in this particular case, what we're actually doing to solve the problem is we're taking data and actually working through what we call a data pipeline. And this is an illustration of something that my current employer does, Pentaho. They actually do it with a technology called visual MapReduce, which allows you to work through the data pipeline as you take it from its initial raw format and turn it into a format that's actually much more usable from an enterprise data warehouse perspective. So this is a pipeline that most companies historically have done by manually coding MapReduce in a Hadoop context. That's a very painful and problematic way to solve the problem, and you can have some quality issues associated with deploying that solution. I'm trying not to put any vendor plugs in this pitch because this is really an educational session. So what I'll just say is that Pentaho facilitates this by doing it all automatically. It automatically generates the MapReduce code, which makes it much faster and much less error-prone. But the idea here for illustration purposes is you take this initial data set, you run it through a data pipeline where you're cleaning, you're taking certain fields out, you're adding some context and enriching the data, and out of that whole pipeline comes out something that's much more usable to help you solve the specific problem you're trying to solve here, which is where is my excess capacity and how can I solve something? So at that point, now you're opening up to some of the stuff that we talked about a little earlier, which is running SQL over Hadoop. And these graphs on the right-hand side are representative of what Pentaho typically does. So you get a number of different ways to visualize your data as you query your Hadoop data sets or your legacy data warehouse sets. You can use heat maps, you can use pie charts, you can use territorial graphs. And we actually have a demo that I'm not going to show you today that actually literally illustrates here's exactly where your spare capacity is geographically in the United States. So that's where you want to go to actually focus on generating extra revenue on the weekends when you can resell that spare capacity. So this is really the sort of summary slide. I just got, I think, a hook in terms of finishing off. Hopefully we'll have a few minutes to ask questions here. So the reason this is a great use case for people getting their feet wet with Hadoop is that it raises your top line revenue if you do it right, and it lowers your bottom line cost. And if you're a CIO, you're probably going to fund any use case that has a very clear objection to either one of those two areas, but the strategic ones associated with raising revenue, those are the ones that get people's attention quickly. So as long as you can have a coherent conversation with your CIO around how taking this project is going to allow you to raise your revenue, that's a really good solution, and it's going to get fast-tracked. And also, by taking this approach, you get some hands-on experience with this new technology, which can take a while to learn because it's so complex. So you increase your revenue and you lower your costs. And using Hadoop as an active archive kind of a layer actually is a much more cost-effective solution, not just for enterprise data warehouse, but other sort of relational environments as well. So you don't have to limit yourself to treating Hadoop as an archive layer for just one environment. You can actually plug other data sources into it and let it be an active archive for all that. And I see a lot of evolution of Hadoop as a solution for that specific use case in the next couple of years as well. And really what you're getting here is context, right? Social media is a great tool for understanding what are people really thinking about as they transact with your brand. But to be able to mine that data and to take advantage of it is still kind of a little bit of a black art, and this is a way to actually get your hands dirty with how to do that and get some social media context that really allows you to get closer to your customers. No, I have one other point I wanted to make. Leveraging the ecosystem. So as I think the point was made earlier that this is fairly complex stuff. Trying to do it yourself, you can do that if you want, but I think you probably want to take advantage of the value that some of the vendors in the space and some of the systems integrators in the space can offer you, because it is a fairly complex solution to deploy, relatively speaking. So taking advantage of the right partners can really help speed the path towards productivity and minimize any sort of transactional pain that you might get as you implement this kind of a solution. So this is my contact information. I don't have any business cards yet because I just started at Pentaho, but feel free to give me a call, drop me an email. I don't really tweet very much because I haven't figured out how to do that stuff productively yet, but connect up with me offline if you want to ask any more questions, and I'll be around for a couple minutes for questions here if you want to ask them. Yes?
I don't think you can tweet productively. No one figured that out.
Thank you. I thought it was just me.
No. Listen, here's my question. The storage technologies themselves are changing. When we're talking about software-defined networking, software-defined storage,
Yeah.
we're talking about new kinds of flash storage arrays with storage controllers that you'll be moving pieces of your big data algorithms into on the fly to execute against the data. You didn't touch on any of that in your presentation,
Right.
not obviously.
Yeah.
How is that changing the acceptance or integration or innovation rate using Hadoop?
Great question. So, for those of you who didn't really hear the question, it was around adoption of emerging technologies like Flash and very low latency, very high speed storage subsystems as it relates to Hadoop as a whole. What's the adoption rate there? In my experience, it's actually not been that great, and here's why. If you go back to the virtualized file system area, right? If you're virtualizing your file system before it ever gets to the storage layer, you're probably going to have some I/O issues right there. So the ability for a Hadoop stack to really take advantage of truly low latency, high speed storage environments is fairly limited because the file system is virtualized to begin with. The other thing that sort of resists innovation in that area is the reference architecture around Hadoop, which is designed to leverage DAS, right? Direct attached storage. So the whole notion there is you're going to use a commodity box, you want it to be cheap, so it's probably going to have spindles on it, and just leverage that because throwing a lot more money at the hardware layer isn't necessarily going to solve your problem. And there are ways to actually get around that and really leverage Flash, innovate from an innovative perspective, but that's still kind of emerging in the software layers, so it'll be a while before those solutions can really be taken advantage of in an enterprise Hadoop context. That's kind of my experience in the space so far. So there is some definite potential. I did see a lot of innovation from companies like Fusion.io as an example, right? So they have some really interesting technologies that you can leverage in certain ways, but where that really tends to show up first in a Hadoop context is in the NoSQL subset of Hadoop. And I haven't really talked at all about NoSQL because it wasn't on the agenda for today, but for transactional workloads, NoSQL solutions are typically what's being deployed to help solve that problem. And I do see reference architectures leveraging Flash subsystems for transactional solutions like MongoDB and Cassandra, right? Those are the reference architectures that tend to take best advantage of those solutions. There's a subset of Hadoop called, it's funny, I used to talk about this all the time, now I can't remember. There's actually a HBase, sorry. HBase is the actual transactional solution that comes with the Hadoop stack. It has some different challenges in terms of adoption in the market, but it will eventually be able to take care of those, or take advantage of those technologies as well.
It's a related question. And there are some studies, efforts, like not based on the HDFS, but parallel file system cluster.
Yep.
Like
question for those of you who didn't hear it is, how do you see?
It's already doing it.
Yeah, so there are some vendors in the Hadoop space who can take advantage of non-HDFS file systems, parallelized file systems. The interface between the application layers and the file system is fairly well defined from an HDFS perspective, so trying to bolt on another file system and how successful that will be really largely depends on your ability to implement the HDFS protocol from those other legacy file systems. So where the rubber really meets the road from that workload is if you look at traditional HPC workloads in the bioinformatics space as an example, genome sequencing, right? I'm just now, literally just now in the last couple of weeks, starting to see companies take a look at legacy HPC workloads and potentially running those on Hadoop. But the technology is still pretty raw there, and I haven't seen anybody really do a lot there. The best they've really been able to do is to leverage something like what MapR can do, which is offer up an NFS interface so you can easily ingest data from an HPC file system into Hadoop.
See a gradual adoption.
It'll happen, for sure it'll happen. What you have to do is go through the HPC workloads, which are data parallel, analyze those and figure out how to migrate those off to a Hadoop stack. The financial pressure of maintaining a legacy HPC environment is pretty expensive. If you can do that more cost effectively and there aren't too many technical inhibitors to do it, then people start to move those workloads.
But
So,
isn't it true that the HPC environment already use a lot of the commodity hardware?
yeah, but the interface between them, InfiniBand, that's not all that cheap. So, I've seen people complain about the cost of maintaining InfiniBand, and now it's driving them.
About the same or less expensive than MPP.
Yeah, so from a hardware perspective, I would disagree with that, but the maintenance associated with maintaining it, I've heard people complain the maintenance cost is what was actually driving to look at it. But the real issue there you're bringing up is what would force people to actually go from an HPC solution to a Hadoop solution? The cost pressure has to be pretty significant for them to seriously get into that. And here in the data warehouse context, a 40x cost differential from a storage perspective, that's pretty big. So that's going to force people to move. I don't think the differential is that big from an HPC to a Hadoop environment. So it'll probably happen, but it'll take longer.
Thank you, Rob.
Yeah, thank you. Sorry, I was running out of time. I can stick around for questions later.